Hello, everyone, and we're here with Martin Lippert from VMware, and we're going to do an interview about the incredible Spring Boot extension for Visual Studio Code. And I'm really excited. So if I do start to just go absolutely off my rocker, it's because I've been using this extension ever since I adopted Visual Studio Code as my core IDE. And I've got Martin here who's going to shed some light onto four core questions that I've got for the interview. One, what is the intro? Two, what is the history? Three, what is the architecture? And finally, what is the features for some of the Visual Studio Code Spring extension? So Martin, first, tell me a little bit about yourself. Give an intro to the extension.
Yeah, my name is Martin. I work for VMware. I live in Germany, in Hamburg, from my home office here. And I've joined the Spring team in 2010. So I'm part of this core Spring engineering team that is doing the Spring framework and Spring Boot and all those extensions and all those frameworks. And my focus is on the tooling. So I'm trying to help developers who work with Spring Boot and Spring Framework and all the Spring projects. And my goal is to make them more productive. And therefore, I'm working with my little team on tooling. So we try to meet you where you are, right, as a developer, like whatever IDE you prefer, whatever IDE you use, and we try to help you. And that's the reason why I'm waking up in the morning and then going to work saying, hey, my goal is to make you more productive. So that's what really drives me doing all this. And before I joined VMware to work on this tooling, I was already involved in some of these things like Eclipse in my spare time and in my previous work doing kind of business architecture, applications and stuff like that. So I'm coming from an agile history and from building up my own company with colleagues about agile consulting and helping people to be more agile, more flexible. But I always had this thought in mind and this feeling of I really liked to help other people and make them more productive, either with the agile process and things like that and helping them, but also on the tooling side. To give them more tools, to allow them to adopt certain technologies, to play around with certain things, to really use more and other new things in production, in their systems, to improve their lives, basically, as developers. And that's why I moved into the tooling space, because I think that's kind of the optimal thing. I love writing software, and I love software engineering. And now I do software engineering for other software engineers. So that's what really drives me, and that's what I love so much.
And I can feel the passion. And we've got 2 million active Java developers on the collection of our Visual Studio Code extensions. And definitely by far, the Spring extension is our most popular and our most loved. And it's been around since 2017. And that's I think about 7 years already, and there's been a lot of milestones around that. There's some new features. What I really love about it though, and it evolves as users evolve. One of the new features, which I'm hoping that you'll touch on, is the new Spring Getting Started extension, which is a fascinating new wizard that allows people to actually get started just with a few clicks. But before we get to that, I want to go through a little bit about how does it work under the hood. I had a candid interview, pre-interview with you before, and I said that for a very long time I was hooked on Visual Studio Code because of the language server. Can you touch on the architecture behind all of the extensions, the Spring Boot extensions, and how does the language server really play a pivotal role in that architecture?
Yeah, sure. Yeah, super happy to do that. So you mentioned that the VSCode extension for Spring exists since 2017 around, but the real history of the Spring tools on their own goes way back, right? I think the first incarnation of the Spring tooling for IDEs was invented around about 2006, 2007. when a small group of developers, I think it was Christian Dupuy and Thorsten Jürgeleit, who used Eclipse as a platform, because Eclipse was one of the most famous IDEs out there. It was free. It had great Java tooling back then. It still has, and it had a great extensibility story. So it was kind of the first IDEs who really adopted these. You can extend everything, and the IDE is a platform for building additional extensions on top of that. So they went ahead and they built the first Spring IDE. That was the name back then, the Spring IDE project, as extensions to Eclipse back then. And everything was built as extension for Eclipse. It was written in Java because Eclipse required you to kind of write extensions in Java and adopt their style of writing plugins and adopt the APIs of the Eclipse platform under the hood. So that was basically the way you did those extensions for IDEs back then. And that's the same way as many people did those extensions, like extensions for other languages, extensions for other frameworks, extensions for other platforms, and things like that. For example, there's a group who built C and C++ tooling for Eclipse back then, and they really had to implement everything in Java because all these extensions were running inside of the same process, the same JVM as the IDE itself. You were extending the IDE in process, right? So you contributed your jar files and your class files and whatever, and when the IDE started up, all those extensions were running inside of the same JVM. So they had basically to implement all the kind of the C++ tooling in Java, which is sort of, it's a little bit weird and crazy because you have to write a parser for C and C++ in Java, even though maybe there exist already parsers for C and C++ in C, written in C++. Because usually, as we all know, right, people who invent languages, they also like to write the compilers and parsers with their own language, which makes sense, right? Eating their own dog food. So that's awesome. But when you went the step ahead and tried to integrate those languages and those frameworks into the IDEs, you had to basically adopt all these APIs of those IDEs. In this case, it was Eclipse, and that's what the team did back then. They adopted the Eclipse API and implemented everything on top of the Eclipse API in Java, and that grew a lot over time. But when kind of the IDE landscape changed over time, it became clear that maybe you don't really want to force people to use a specific IDE, right? Of course, kind of Eclipse was the dominant player back then, but over time, people were using other IDEs, other environments, other coding environments. Some people liked Eclipse. Some people still like more lightweight editors, because Eclipse became more heavyweight and more integrated, and everything was integrated into this kind of huge IDE that gave you everything basically. So there was kind of a tension coming up between more highly integrated IDEs and more kind of very lightweight, very simple to use editors. And that was the time when VSCode came along, basically, on the side of the very lightweight, very small, very simple to use editor-centric coding environments, not giving you all the things highly integrated into the IDE space, but really focusing on this lightweight editor thing. But they also wanted to give you the option to help you with working with certain languages and being open and being extensible, because that was a great success story of the Eclipse time. So they decided to kind of adopt a slightly different architecture for VSCode and not let people write all the extensions for VSCode in TypeScript, which is the language that VSCode is written in and running on top. But instead, defining something like a protocol, this language server protocol that sits between the editor or the client on the one side. The editor in this case is the client, and something they call the language server. So kind of a different process, really being able to analyze the language and giving you content assist and doing whatever is necessary to give you great tooling for a certain language. So that was I think, a brilliant idea to really decouple the way the IDE or the editor was implemented from the way the language server and the language tooling was implemented. So you were able, since those two different things, like the client and the language server, they were running in separate processes and communicating basically via a protocol based on JSON RPC. So once you have this architecture in place, you can do things like implement your C++ tooling in C++, right? And run that as a process in C++, and still have the client, VSCode in this case, implemented being running on TypeScript and running on the V8 engine, basically. And this allowed us, for example, or this allowed a huge crowd in the world to really think about this as two different things, right? So you focus on, for example, building language tooling, and you implement that in the way that you think makes sense in the language that you choose. And to the outside world, you talk this protocol. And on the other side, there's the client like VSCode using this, right? And asking the language server, oh, please give me content assist for this file, or please give me some additional features like navigation and symbols and all those kind of things. And then, since you had this kind of decoupling between these two sides, people were starting to also implement other clients talking the same protocol. So some like existing IDEs or simple editors were also talking about, oh, I can understand the language server protocol, so now I can use all the language servers that exist out in the world. Since I talk the protocol, I now get language tooling for C and C++ in, for example, in my Emacs editor, right? Because there's an extension for Emacs that talks the language server protocol. And that was kind of when this architecture really got invented, we adopted this architecture for the Spring tooling as well, because we were in the situation where we have built the Spring tooling for Eclipse based on all these IDE, all these APIs in Eclipse in Java. And building that in Java makes sense for us because it's a Java framework. But really being highly coupled to this Eclipse IDE didn't really made any sense to us anymore, because there were kind of other environments coming up, like VS Code, and maybe people using cloud IDs in the future and things like that. So we wanted to focus on the Spring tooling at its own, right? This exclusively focus on the Spring tooling and invest all our energy in building great Spring support for developers out in the world, independent of which IDE they use and which IDE they choose. And these VS Code architecture, this language server protocol, basically, this would kind of sound like a brilliant solution. We were even kind of playing with something like that before VS Code came along and did something like this under the hood as kind of experiments internally. So we were kind of already moving into this direction. And then VS Code came along, and this architecture came along and say, oh, wow, that's exactly what we need. And then we made a big shift, right? Before, we had these kind of Spring Tool Suite for Eclipse, Spring Tool Suite version 3, and the extensions for Eclipse, and that was it. And then we moved over to this language server protocol, so we more or less re-implemented everything, or not really everything, but huge parts of the Spring tooling. We re-implemented them, those features, and put them into a language server, and integrated this language server back into Eclipse as one step, and integrating that into VS Code on the other side. So we had this one language server for the Spring tooling that we were building up from the ground, and shipping that as part of extensions for Eclipse and VS Code at the same time. That way, we were able to sort of slowly replace the existing Spring tooling for Eclipse with a new architecture, because there's also an extension for Eclipse that allows you to adopt the language server protocol. So people were able to continue to use Spring Tool 3. They were doing that using Eclipse as they did in the past. Then they were able to jump to the Spring Tools 4 based on Eclipse and continue to use that, even though under the hood, all the tooling really changed quite dramatically from an architectural point of view. And then we were able to ship these two extensions. And that opened up the door, for example, for many other IDEs. Nowadays, there are many other coding environments that also adopt the language server protocol, or they even adopt the VSCode API for implementing IDE extensions, or adopt the open source VSCode project. So, for example, in GitHub Codespaces or in Gitpod or some cloud IDEs like that, you are able to use exactly the VS Code extensions. But the real step forward for us was really to shift architecturally from these building everything on an Eclipse API towards building more or less everything, or as much as we can, into a language server once, and then plug that into different coding environments. I think that was kind of the big architecture shift. And that is what we did between, I think, 2016 to 2018, around about that, right? I think the first beta came out in 2017, and the first release came out in 2018 or so. And since then, we are really focusing on this language server and shipping new versions and shipping new features, part of this more or less language server that we package into a VS Code extension as well as Eclipse extension. We still ship the Eclipse distribution, which comes as a kind of a ready-to-use distribution of Eclipse, bundled with these Spring extensions out of the box. But the real stuff is inside of this language server, which is IDE agnostic.
That is fascinating. I really, if you had told me all of this when I'd started fanboying, I would have never thought, because I came from a background where IDEs, you paid tens of thousands of dollars and you got something heavyweight, and it only ran one language, and it only did certain features though. And now I'm looking at the features for the Spring extensions, and you're adding all of these incredible features onto the extensions. One of them is the Spring initializer. So the next question I have for you is, what are some of the features that developers can use in the Spring Boot extension?
Yeah, I think the stuff that we really focus on, it groups into different areas, basically. One area is the getting started experience. So we would like to make it really easy and really fast for you to get started with a new project, with a new Spring Boot project in your IDE. That's where all these integrations for start.spring.io and for the Spring initializer, for Spring guides and things like that, where they all belong to, right? Usually, what people do, they go to start.spring.io and they choose their modules and the extensions and kind of click some config options, and then they download a zip file with a generated project stop, and then they can start coding. And that is awesome, right? You can still do that with your favorite IDE, but we try to bridge this gap between going to the browser, typing everything in, downloading a zip file, unzipping the zip file, importing the project into the IDE, and get rid of all these tedious steps, and put this integration directly into the IDE, so that you can basically, in your coding environment like VS Code, you can say, create me a new Spring Boot project, and it gives you exactly the same options. It asks you for exactly the same options that start.spring.io has, gives you the option to select the modules, and then you get the project directly in your IDE, ready, unzipped on disk. This is the cool thing about that is it's automatically adopting to all the changes that happen on start.spring.io. So it's not a statically built UI for this initialize integration. It's really using metadata that comes from start.spring.io, because the start.spring.io web service also has an API that you can use to get all these metadata information about what are all the options that are available, what are all the modules, what are the modules for the Spring Boot version if you select whatever, and then generate the project. And we just use that API, right, and dynamically build up the UI for that in VS Code or in Eclipse or wherever, to give you these options, which is really nice, because if the Spring team decides to add modules to kind of, there's a new Spring Boot version coming out, it's all automatically showing up at start.spring.io, and therefore it also automatically shows up in your IDE extension, even though you don't update to a new version, or we don't have to ship a new version of the initialized integration, for example. So that's kind of one part. It's kind of making it really easy and really fast to get started. And I think with using VS Code and this extension, that's what I do many times in demo sessions, at conferences or meetups or something like that. I think you can get from a plain vanilla VS Code installation with no extensions installed to a ready setup environment with Java and Spring tooling, and your first Spring Boot project freshly created with the service up and running and debugging your IDE. You can get there in under a minute, right? You can get there in basically in seconds, right? And that's, I think, really, really awesome, really great. I think really great achievement, really great step forward. A cool thing here is also, and that's something that's probably that's a little bit unknown, but companies, they really like this initializer project, and they really like to use that and host that in-house, so that they have their own instance of the Spring initializer, so that their own employees, they don't go to start.spring.io, but to start.mycompany. And they customize that a little bit so that the projects that are being created really fit the needs of the company, right? Company guidelines, certain default modules, whatever the company thinks Spring projects should look like. And in the tooling, there's the option to switch the tooling over to use a different API endpoint. So not go to the API of start.spring.io, but go to the initializer instance that is running at a different URL, basically. So if you're working inside of a company and your company hosts their own version of the initializer project running somewhere internally, you can switch your tooling over to that URL, and then you automatically get all the options and all these config or less config options, whatever, that this specially custom hosted version of initializer is providing you. So that's, I think, that's really, really nice for those companies. And we don't have to switch the tooling for that, because the tooling uses the dynamic data generated by the metadata generated by the initialize instance to render all the UI and give you all the options. And that works really nicely. So that's the getting started part, right? That I think is really cool. The second big part where we invest a lot of energy into is making it easier for you to work with your existing Spring projects, and that means giving you Spring-specific contenances, Spring-specific navigation, Spring-specific information, things like that. I think one of the kind of obvious and famous examples is if you implement, or if you work on your application.properties file. It's usually kind of, you have all the options from Spring Boot, and there are kind of thousands and thousands of property keys that you can use to customize your application and configure it with all these options. And I forget about all these options, and I don't keep them in mind, and you Google them or whatever. But there is metadata out there for all these config options as well, embedded in the libraries. So Spring Boot comes with metadata about the config options of Spring Boot. Spring Data does the same, and Spring Cloud, and all these projects. And the tooling can read all this metadata and give you contenances based on this metadata for editing application and property files. So it gives you all these validations, right? If you have a typo in your properties key, it will give you directly a warning saying this property key does not exist. If you have a typo in your values, right? For example, if there's an enum, like it log levels, right? You configure log level, and you have a typo in there, it will tell you that, because it knows that log levels it's really an enum consisting out of 6 or 7 or whatever specific values that you have to put in here. If you define your server port, right, you switch that over. It knows that the server port is a number, is an integer in a certain range. It gives you errors and warnings if you do something wrong. Right? So it gives you this information directly in the IDE, as you would expect from a good IDE. Like if you implement Java code, you don't really want to wait for the compiler to compile, or you don't want to wait for the application to run to tell you, oh, you forgot a closing bracket. Oh, you mistyped a keyword. Oh, this method does not exist. Oh, you put a wrong parameter in somewhere. You expect the IDE to tell you that ahead of time, right away, while typing. And we enhance that for Spring-specific constructs. So everything that we know about Spring, we put into this IDE extension to give you this information right away while you're typing. So making you faster, right? You don't have to wait for running your Spring Boot application and then finding out, oh, the properties key is wrong. Oh my God, why is the database not configured correctly? You see that directly inside of the IDE when you open the file. Errors, warnings showing up, help when you hover over things and stuff like that. And this does not only apply for kind of application.properties files. The same works for application.yaml files. So if you work with YAML-based configuration files, of course, we have exactly the same, all the same content assist and hover help and validation in place for that. And if you work with Java code, of course, as well, right? So if you have a spell expression in your Spring annotation somewhere, and the spell expression has a mistake, a grammar mistake, is not a valid spell expression, the IDE will tell you that, even though it's from a really source code perspective, it's just kind of a string inside of the parameters of the spell expression annotation. But we know that, right? We know, oh, this is an annotation that expects a spell expression. Whatever comes in as an expression, as a string here, is a spell expression. So we can evaluate that. We can validate whether this is a correct one or not. Same is for value annotations, where we can give you content assist about the property keys and things like that. Right? There are a lot of those little features here and there that makes coding with Spring-specific constructs easier for you and give you help, basically in these kind of giving you help, like hover help, giving you content assist, and doing validation for you. Same with kind of little code snippets and templates that we can easily generate for you if you implement a REST controller, right? And we know, oh, you're inside of a REST controller, so that means you will probably want to write a method that accepts is a get mapping or a post mapping or whatever. So we give you little code snippets for that. Makes it really easy for you to do that. And that's kind of working with the code. And the other part, when you look at the source code, is understanding the code, right? When you look at your Spring application, you usually have Spring concepts in mind. You don't just think in terms of there's a Java class, or there's a method, or there's a field, or there's a package. You think about, oh, this is a controller. Oh, this is a repository. Oh, there's a configuration class where I configure my beans that I want to use. All those kind of things. And this is something that you have in mind when working with Spring applications. And we try to lift up the IDE knowledge around those concepts as well, so that we can give you navigation and understanding about, hey, where are all my controllers? Right? What are all the request mappings that I have defined in my project? And we know that, right? The IDE knows that because it understands Spring. It understands what you're doing, at least up to a certain degree, right? It cannot understand everything. And gives you these as kind of symbols. So it can super easily navigate and see all the request mappings, all the beans that you have defined, so that you can work with the IDE more directly with these same concepts in mind that Spring gives you, right? These There's a controller, there's a repository, there are beans, there's dependency injection, things like that. And this navigation, I think, is really, really powerful. It only gives you a perspective of the source code, right? Allows you to quickly jump and navigate inside of your source code and find the right bits and pieces, and gives you an overview about what is all there. And there are different options. One is, for example, the Spring Boot dashboard in VSCode, the extension. It's all included in the Spring Tools extension pack. But the dashboard gives you kind of a little views about, hey, here are all my request mappings, and here are all my beans. And with the command palette, you can search for workspace symbols, and then you see all the symbols of all different kinds, like all request mappings, all beans, all repositories, all functions, all add configuration classes, things like that. And the tooling is kind of looking at your source code and analyzing your source code to give you this information. And the cool thing is that the tooling is really a little bit, it's a little bit smarter than just looking at your source code, because it looks at Springy source code. So it knows that if you look for an add configuration annotation, for example, if you look for where are all my configuration classes, basically, it knows that there are classes that have an add configuration annotation on them. And that's, of course, part of the result. But there are also classes that are not annotated with add configuration, maybe classes annotated with a more specific annotation that has add configuration as a meta annotation. You don't see that when looking at your source code, but the tooling can analyze that and knows that. So if you have a add Spring Boot application annotated class, it knows that, oh, add Spring Boot application is also an add configuration class. So it gives you this as a result as well, if you look for all add configuration classes, for example, which I think is really, really, really nice and really, really useful. It's kind of just a small little bit of smartness that we put into the tooling, but it makes really feel fluent and it's very springy, that you understand all these concepts in a reasonable way. That's kind of the second part, kind of working with your source code, right? Getting started, first part. Second part is working with your source code. And the third part that we do kind of, I think, two more areas, kind of the third and the fourth part. The third part is really giving you information about the running application. And the running application is sometimes a bit tricky, because you look at your source code, right, and you see you have your source code written, you've added certain annotations, you configured your dependency injection. Spring Boot does a lot of auto configuration for you that you don't have to think about. It does all that for you, but it's not really totally obvious all the time when you just look at the source code. And then you start up your application, and somehow the application behaves maybe differently than you would expect this from looking at your source code. So you build up this mental model of you're trying to bridge these two worlds, right? What happens at runtime? What is exactly going on in my running application? And how does it fit to the source code that I'm looking at? And sometimes it feels like, oh yeah, usually it's all working as expected, of course. But there's a certain situation where I think something is different. Something is a little bit weird. What exactly is going on? And then you really try to find out what's going on at runtime. And in Spring Boot, you have the module called the Spring Boot actuators. And the Spring Boot actuators, they really allow you, for example, to open up information to the outside world from the running Spring Boot application. I think it's very often used in kind of if you deploy your Spring with Kubernetes, these liveness and readiness probes and things like that. But the actuators can give you a lot more information of the running application, can give you information about what is really going on inside, like what are all the beans that are created? How are all the beans wired? So which bean depends on which other bean? What are all the request mappings that are really active, and what's the controller that actually really implements at runtime this specific URL path, for example? What are all the conditions, like the add conditional annotations? What happened to them, right? Which conditions have been met at runtime, which not, and if not, why not? things like that, and a lot more, right? You can get metrics and all those kind of things. Huge set. So we're using the Spring Boot actuators in the IDE tooling. So when you start your Spring Boot app, it has actuators on the class path. We fetch this information out of the running application, and we map that, we display that in the IDE directly side by side with your source code. So you can see this in the Spring Boot dashboard, where the static beans, they switch to showing you the beans that are live, right? That really exist in your application, or showing the request members that really exist in your application. And then we go one step further and try to bridge this gap that I described, this mental model that you build up between stuff that is in your source code and stuff that is in your running application. How does it fit together? We try to really do that for you by using this dynamic information of the application, and then overlay that onto the source code where we think this belongs. So there's a bean defined in your source code, and this bean exists at runtime. We highlight that and give you the information this bean exists. When this bean has certain dependencies that got injected, we can show you in the source code directly, this bean gets this other bean injected, and this other bean is defined in this source code file. To really directly put this dynamic information from the running app onto the source code, that you can really see it in the same place by looking at your source code. And that's what we call these live information, right? The live hovers and the live information from running Spring Boot applications. And one really cool thing about that is that from the architecture point of view, we're using the Spring Boot actuators for that. But this works not only for apps that you run locally on your machine from your IDE, right? We automated that, so that works out of the box. You can just start up your Spring Boot application in VSCode. You have actuators on the class path, and it automatically shows you all this live information right away out of the box, right? Nothing you have to do. If you run your Spring Boot app somewhere else, right? You put that into a container, you run that inside of a Docker container locally. You run that on a local Kubernetes. You run that on a remote Kubernetes, whatever. And you can configure this application and say, oh, this actuator information, please make this available. Like in Kubernetes, you would do a port forward from this HTTP endpoint where the actuator is being exposed to, port forward. Or same inside of a Docker container, you would maybe also port forward a certain port from this Docker container. And then you can configure the IDE, say, oh, please fetch this information from over here or over there. And that gives you, displays the same information from the running Spring Boot application, running in a Docker container, running Kubernetes, running somewhere, or basically anywhere, as long as you get this connection to your local machine, to display the same information in your IDE. And that way, you can even do both at the same time, right? You can say, oh, I have my project in my workspace. I run it locally. I run my Spring Boot app, right? It shows you live information from the locally running thing. That's awesome. And then you connect that to maybe the same application running inside of a Docker container somewhere. And if you configure that to show this live information from this Docker container as well, it will show you both in the IDE. So you see that side by side. You can even compare that. Right? You can see, oh, this bean is active in my local application, but it's not active in the Docker container version. Right? You see this information. You can even see the difference. Right? You have to analyze the difference yourself. We don't do automated diff analytics for that. Maybe an interesting thought for another feature in the future. But you can see both at the same time, which I think is really, really cool. That's the live information, and giving you live information out of your running Spring Boot application. And then there's the fourth area, which is the latest addition to the Spring tools, which I think is really it's just the first step. It's a really, really small and simple first increment into a whole new space of tooling features, because we try to help you keeping your projects up to date with the latest Spring Boot versions. Right? You have Spring Boot applications, and there's a new version of Spring Boot coming out every once in a while, right? quite frequently. For example, in your patch release, if there's a CVE coming along, bug fixes coming along, patch releases of all the different Spring Boot versions are being released all the time. And you always, of course, want to stay up to date with the latest patch release. Maybe you even want to update your project once in a while to a new minor release. And certain points in time, even to a new major release. Like recently, Spring Boot 3 came along. So people are now looking at upgrading their existing projects to Spring Boot 3. And if you think about these kind of these three steps, right? Updating patch versions, updating minor versions, updating major versions, they come at a different, let's say, scale of complexity. Upgrading to a new patch release, it's fairly easy. Usually, you just change the version of the parent POM, and then it's fine. The version of the parent POM should be fine. In some cases, you need to adopt small things, maybe like in the latest Spring Boot patch release of Spring Boot 277 to 278. I think there's, for example, a change in the Maven connector, the MySQL connector, the MySQL database connector. You need to switch that to a new artifact ID because it's kind of adopting the version of that, slightly new version, but that is moved. But it's still a fairly simple change. Nevertheless, you have to do that. And for minor versions and major versions, you usually get a quite comprehensive and well-written migration guide from the Spring team, tells you all the steps and all the changes that happen and what you basically should do to jump to this new version. And this consumes time, right? And sometimes those changes are quite time consuming. Sometimes they are a little bit tedious because you have to do the same thing and maybe across hundreds of files of your source code. For example, think about switching from Spring Boot 2.7 to Spring Boot 3.0, and you use a lot of JavaX persistence packages. You need to switch them over to Jakarta packages. So you have to switch all the imports to import the corresponding Jakarta classes. So what we are trying to do now with the Spring tools is really help you with it. And the first step is to give you information about new versions. So with the latest version of the Spring tools, you will see these validations, these warnings and errors and information showing up when a new Spring Boot version is detected. So if the tooling sees you're using Spring Boot version 2.7.7, but there's 2.7.8 out there, it will tell you, hey, there's a new patch version out there, 2.7.8. Same for minor and the major version. You can configure that. So relax, no need to worry about having thousands of warnings about, oh, there's a new major version. You can configure that, right? So if you're interested in, please show me patch versions only, please show me new minor versions as well. Always show me the latest major version update as well, whatever. You can do that. You can configure that to your needs, but you can always stay up to date from an informational point of view, right? You see always the latest version of the Spring Boot version in this case. And this is focused on the Spring Boot for the moment, right, as a first step. And the next logical step is, of course, you would like to update to that version, right? If there's a new patch version, you would like to update your project. If there's a new minor version, maybe you even want to upgrade your project once in a while to the new minor version or new major version. And for that, of course, the next logical step is help you with that as well. And that's what we do as a first step, right? When there's an information coming up about this new patch version, there's a quick fix for you that updates your project to the new patch version. And if there is, at the moment, this update to a new patch version, it only updates really the version of the parent POM in your POM file. And it does not work for Gradle builds yet. Working on that. That will come in the future. But for Maven, we'll just update the version because we expect kind of small change. Just update the version of the parent POM. In the future, we might also kind of adopt these little additional things that come along with new patch versions. but that's a little bit up in the air. Let's see. If you want to update to a new minor or a new major version, there's also a quick fix for that available. And this quick fix not only changes the version of the parent POM, but really walks through something like a codified version of this whole migration guide for the Spring Boot versions and executes all those steps that can be automated or that we already have automated automatically on your project. This will probably not cover everything that you need to change. Not everything will be changed fully automatically for you, but we aim at automating as much as possible for you, so that if you want to, for example, upgrade your Spring Boot 2.7 to Spring Boot 3 project, and you run the migration, you execute the quick fix, it runs the full migration script, it adopts all your Jakarta imports, it adopts the version of the parent POM, it injects new dependencies in your POM file where necessary, it changes property keys in your property files that have changed, many more things, right? As much as possible from this migration guide that you need to do. It even looks at your source code to see because you jump to Java 17, it looks at things like, what are all the things that I need to clean up maybe for Java 17? Or what are annotations from Spring that are no longer used, no longer necessary, and we'll clean them up. And this is, I think, really, really awesome, because it lowers the amount of work that you need to do, the amount of effort that you need to invest into upgrading to new Spring Boot versions dramatically. Right? It gets a lot easier to always stay on top of the latest Spring Boot version if you really want that. On the different levels, like on the latest patch version, latest minor version, or the latest major version. Under the hood, architecturally, this part is based on an open source project called Open Rewrite, where we also try to kind of not reinvent the wheel ourselves again, but try to reuse existing technology for these project migrations and changing the source code and adopting source code automatically to a new version of a framework. And that is what Open Rewrite really is for, because it gives you a lot of these basic constructs, like basic changes, little small refactorings and changes to your source code. And you can assemble basically this codified migration guide. You can assemble this codified migration guide out of these small steps, many small steps, and assemble a whole big recipe for this migration from Spring Boot 2.7 to Spring Boot 3, for example. And the tooling integrates that and uses that under the hood as the engine, so that it really benefits from a lot of the community work, of course. So people can look at the source code. They can look at exactly what happens when I migrate my project using this recipe. Is there anything missing? They can even contribute new recipes, new code changes, missing code changes, and things like that to the Open Rewrite project. And then we can integrate that back into the Spring tooling and adopt that. And what I think is pretty cool about this way of dealing with these migrations is, since we are reusing this Open Rewrite technology, people can also start to implement their own code changes. So, for example, you're inside of a company, you have many projects that use a certain construct, that use a certain library, that use something very specific to your company, and you need to migrate many projects maybe to a new version of Spring, or a new version of this library, or you want to modernize that. You can implement those little code changes using Open Rewrite yourself, put these recipes together and define them and configure them in the way that fits your needs. And in the tooling, we are able to use that, right? So if you want to, you can configure the Spring tools to also not only show you the 3 standard recipes that we give you, like these convert the different Spring Boot versions, but if you define your own ones, you can configure that, and you can even run your own recipes directly from the IDE if you want to. In case you want to. It's not the only way to execute those code changes. You can also execute them automatically in your CI builds because they're integrated in your build environment, your build tools, so they can also run as part of Maven or whatever. But that's kind of part of Open Rewrite, right? You can look at that and different options to use that. My goal here is to make this available and surface that as part of the IDE tooling and put that directly into the hands of our developers to really make them more productive in the IDE. And I think those are the kind of the 4 areas, right? The getting started thing, working with your existing code, giving you live information and making it easy to understand the live running system, and helping you migrating to new Spring Boot versions as the latest addition to the family of those features.
I have so
I hope
much
that gives
reading.
you a nice
I have so
overview.
much reading up to do, Martin. I thought I knew Spring until you actually started with that. I didn't even realize some of those features and functionality. Now I'm going to go, and I'm a developer evangelist for Microsoft, focusing on this. That Open Rewrite sounds absolutely incredible, and there's so many new features. And I love the fact that you've got this mindset that you adopt new technologies as they progress through that, and you evolve through that. Even the all the way going back to the language server protocol, and then making it more versatile. And then currently now with millions of developers actually using this. I looked recently, and the download levels, I had to double take, because the actual Spring extensions, each one of them, each tiny little one, those components that you mentioned, they have millions of views, of downloads for each one of them though. So this is a highly respected, utilized, and loved tool. And it really allows people to do more efficiently and enjoyable experiences within the ecosystem, and for free, which is, like I said to you in the beginning of Java development, I had to buy a car for an IDE. Thank you so much today. There's been a lot. I know that people are going to take back, and they're going to start looking that you can download the Spring Boot extension pack. There's I think there's a 3-pack, and there's also one that actually bundles it up. And allowing them to do the dashboard, the initializer, and also the Spring Boot tools. So like you said, we'll this is one of many of a series of videos that we plan to actually produce, and then going in little bite-sized views of each one of these features that you did. So Martin Lippert from VMware, thank you so much for today's session. I learned a lot, and I'm hoping our viewers learned a lot again. From me, Rory Pretty, cheers everyone. Martin, do you want to say goodbye?
Yeah, thanks for inviting me. Thanks for having me on the show. It was great.
Thanks everyone, and cheers.